All right, Math 2, here we go. We got lesson 5.1.4, writing equations for quadratic functions. All right, so we're going to do a little bit of review. We're going to solve these using the zero products property. Remember, the zero products property says that we factor and then set the factors equal to 0. We can find the solutions to the equation. So this first one, since I don't have a leading coefficient, this is a problem where I could just do the diamond method, and I ask myself what multiplies to give me 8, but adds to give me 6. So it multiplies to give me 8, adds to give me 6. That should be 4 and 2. So we don't really need the area model for this one, because we've learned that our two factors are just going to be x plus 4 and x plus 2. Okay, so the zero product says if I'm multiplying things, which I am, and they're equal to 0, then one of them has to be 0. So x plus 4 could be 0, and x plus 2 could be 0. Because anything times 0 is 0. To solve it, I would subtract 4 from both sides, and I get x equals negative 4. And my other answer is x equals negative 2. Remember, when we solve for these problems, if this were a graph, these would be the x-intercepts of the graph. So we call these the solutions to the quadratic. We also call them the roots of the quadratic. What are the other names? There's like 4 different names for what these are. So these are the x-intercepts. They're the solutions to the quadratic, the roots of the quadratic. There's something else I'm missing. It doesn't matter. Anyways, moving on. Next one, we're going to factor it. We can factor this one by GCF because I can factor out an x on this one. So I've got x times x plus 6. So it's a multiplication problem where when you multiply, you get 0. So one of these should be 0. So x could be 0. And x plus 6 could be 0. So I already have one of my answers. One of my answers is 0. My other answer, I subtract 6 from both sides and get x equals negative 6. So again, those are the roots of the equation, the solution to the quadratic, or we can say that those are the x-intercepts in the graph. Next one. This one's already factored for me. So I have 3 factors here. 3 is a factor, x minus 5 is a factor, 2x plus 3 is a factor. If I do 3 equals 0, that doesn't make any sense. 3 is never 0. So I'm not getting any answers from this one. Basically, if it doesn't have an x with it, you're not going to get an answer. So 3 can't be 0, so there's no way to solve that first part. But I can solve this part. X minus 5 could be 0. And 2x plus 3 could be 0. For this one, I would add 5 to both sides, and there's one of my answers. One of my answers is 5. For the other one, I'd subtract 3 from both sides, get 2x is equal to negative 3, and then divide by 2, and we get x equals negative 3 halves, or negative 1.5. So in this problem, these are the 2 solutions, or the roots of the equation, or these are the x-intercepts. What's the other one? It's killing me that I can't think of the other name. Anyways, moving on. For this one, you can't start by factoring this one. Why? Because we don't have 0 over here. It's called the principle of 0 products, not the principle of 3 products. So my first step is to subtract 3 from both sides. So when I do that, I get x squared plus 4x minus 12 equals 0. Now I'm going to factor it. So for this one, the factoring would probably be the diamond method because we don't have a leading coefficient. So what multiplies to give me negative 12, but adds to give me positive 4. And that would be 6 and negative 2. So 6 times negative 2 is negative 12, and 6 minus 2 is 4. So this one factors into x plus 6, x minus 2 equals 0. So now that I have my 2 factors, and they're equal to 0 over here, I can set my two factors equal to 0 using the principle of zero products. So I get x plus 6 equals 0, x minus 2 equals 0. I subtract 6 from both sides, negative 6. Add 2 to both sides, positive 2. There's my two answers. They're the roots, or we can say that they're the x-intercepts. All right, so we just talked about how these are the x-intercepts. Remember, when you have an x-intercept, the y value is 0. Anytime you cross the x-axis, the y value is 0. So on these ones, we got two different sets of data. We want to write an equation for them. So what I'm going to do to write the equation is find the x-intercepts. Here I have an x-intercept. And then, where's my other one? Here's my other one. So they want us to write an equation for this one. So I'm going to write y equals, and I'm going to do it in factored form. Now notice all of these problems that we did here. See how my answers were negative 4 and negative 2, and I said those are my x-intercepts? Well, where did I get them from? I got them from these numbers up here, positive 4 and positive 2. They're the opposites. So since this is negative 3, the opposite of negative 3 would be x plus 3. Since this is positive 2 as an x-intercept, the opposite would be negative 2. And there's my equation. Now I can go ahead and use the area model and multiply this all out and get x squared plus x minus 6. Now what we see here is if we plug in any of these values over here, I should get the correct y value. Let's plug in 0, that's the easiest one. If I plug in 0 here and 0 here, I get negative 6. And 0, negative 6 is one of the points. So I can see that I've done it correctly. All right, next one. Here is the x-intercept. Here is the other x-intercept. So we can write the equation y equals x. We do the opposite of negative 5, so x plus 5. Remember, we're doing the opposite because way up here, when we had a parenthesis of x plus 4, the x-intercept was the opposite of it. When we had x plus 2, the x-intercept was the opposite. So I'm going backwards now. These are the x-intercepts, so I do the opposite inside of these factors. And then over here, this is x minus 1. If I multiply this out, x times x is x squared. This is 5x with these two. This is negative x, so 5x minus x is 4x. And then 5 times negative 1 is negative 5. So just kind of doing the area model in my head there. And now we're going to double check it. I usually just plug in the 0. So 0 should give me negative 5. If I plug in 0 here, I get 0. 0 here, I get 0. So I get negative 5. Yes, that is what I started with, so everything's cool. Okay, next one says, notice the similarities between this table and the one above on part A. All right, so looking at this, negative 4, 6, negative 4, 12. Negative 3, 0, negative 3, 0. Okay. Negative 2, negative 4, negative 2, negative 8. Negative 1, negative 6, negative 1, negative 12. 0, negative 6, 0, negative 12. All right, so do you see the pattern there? What's happening is we're multiplying everything by 2. Now let's just write from what we were doing before. Let's write the equation here. Y equals, I'm going to leave a little space there because I'm going to need it in a second, x plus 3 times x minus 2. So that's the exact same equation I got here, but this is x squared plus 6 minus plus x minus 6. Now, if I plug 0 into that equation, which is what I've written here, if I plug 0 into that equation, I get negative 6, not negative 12. So that's a little bit of a problem. But what I do notice is 6, 12, negative 4, negative 8, negative 6, negative 12, negative 6, negative 12. All of these are doubled. So what I can do is just write out a 2 over here to double all my answers. So if I write this out, x plus 3 times x minus 2, we said was x squared plus x minus 6. The 2's still out there. We get x squared plus x minus 6. Now if I distribute that 2, I end up with y equals 2x squared plus 2x minus 12. And now when I plug in 0, plug 0 here, plug 0 here, I get negative 12 as my answer, and now it works. So sometimes we need to add a multiplier out here in order for it to make it fit the table that we're doing. Last one. All right, we did a water balloon launch on a previous lesson. Here's their data. We're going to write an equation for it. We've got a slight problem here. We don't have the y-intercepts. Well, I mean, we do. We have one of them, right, or the x-intercepts. We have one x-intercept right here. All right, so now we're going to need to figure out how to make this pattern work when we're going along in order here. So if we have one x-intercept, I need to find the other one. But look at the pattern of the numbers. 0, 9, 16, 21, 24, 25, 24, 21. Whoa! You see what happened there? This was the vertex. Basically what this means is this is going up, hitting 25 for the y value, and then coming back down. See how that's happening? 25 is the vertex right there because we've got a reflection on either side. So this is 24, this is 24, this is 21, this is 21. Which means if this is 16, then 10 should give us 16. 16, 16, 21, 21, 24, 24. So that means if this one is 3, 9, this one should be 11, 9. And then if this one is 2, 0, this one should be 12, 0. There is my other intercept. Okay, now we notice that it is going up and coming back down. So it looks like that. Remember, when we have equations that go up and then come back down, when the parabola is facing down like that, there has to be a negative out front. So I'm going to do y equals negative, and then use the opposite of this and the opposite of this. So x minus 2 and x minus 12. And now it should work when we plug in numbers. So let's just try one of the numbers and see what we get. So I'm going to plug in 3 and see if this works. So y equals negative 3 minus 2, 3 minus 12. So I plugged 3 for the x values into these two and see if it's going to work for my equation. So I get 3 minus 2 is 1. 3 minus 12 is negative 9. Negative 1 times negative 9 is 9. So when I plugged in 3, I did get 9. It looks like my equation works. That's all I got for you today. Math hard. See you later. Bye-bye.